Good morning, everyone. Just few notes. I'm actually a remote worker as well. And my biggest motivation, I used to work part-time, and my biggest motivation to get job done was wake up at 4 a.m. in the morning. So then I was finished at 8 a.m. and have like the whole day in front of me. Just my 2 cents. Anyway, that's not what I would like to talk about today. I would like you to introduce to this relatively new technology called GraphQL. And this technology was originally developed by Facebook in 2012 and open source 3 years later in 2015. And it's more common in the JavaScript community, so I would like to bring it to Python community as well. So before we continue, let me do a quick survey. I hope I can see you through the lights. Please raise your hand if you know what GraphQL is. Oh, cool. That's awesome. So how many of you actually use GraphQL? That's better. That's better than in Bratislava. And finally, how many few of you, how many prefer it over REST? Cool. So yeah, at least one. Awesome. Thank you. So the first thing you need to know about GraphQL that it's a query language. The QL actually stands for query language. And you can use it to build your APIs. It's an alternative for REST, and you can completely replace it. So because it's an API, first thing, if we want to understand the advantages, we need to understand the both parties involved. So just the basic, the API, the I stands for interface, which is usually interface between a client and a server. And I guess here in this audience, we are more familiar with server side than client side, because after all, that's where the Python is. And on the other hand, the client side, usually in JavaScript, that's a bit uncharted area where nobody knows what's this. So I would like to stress the requirements of client sides every time it's possible, because it's actually harder to understand someone else's problem than our own. And it affected the design of this language a lot. So if I should tell you, if I wanted to explain what's GraphQL in 30 seconds or less, I would use the example from GraphQL homepage. Basically, the server describes the data in a schema. You can use the query language to query the specific data from the server, and the server returns the data in exactly the same shape as you requested. And this is the most important attribute of GraphQL, that the shape of a response is always defined by a client and not by a server. How is it in REST? So just let's take a step aside and talk about REST for a while. REST is a simple and very nice architecture for APIs, usually implemented using basic HTTP calls. We have GET request to query data from the server, and we have post, put, patch, delete to modify them. The ST in the shortcut REST actually stands for state. So we could also say that we have read operation for reading the state, and write operation for mutating the state. So in REST, we simply send an HTTP call to the server, and the server gives us the data. And what's important, it always gives us the same response, no matter if you only need only a subset from the data or if we need some extra data. So when we are designing a REST API, at the beginning, we need to get the requirements of a client and what the server is capable of, and find somehow the middle ground, which is best for the performance for both sides. But the problem is, when the requirements change, we need to redesign our API. So one problem we might get with REST is called overfetching. Basically, if we request the data from the server, and we actually need only a subset of the data, we are overfetching the state. And if we are on, for example, a slow connection, it might affect us. If you ever used GitHub API, you know it gives you quite a lot of data. And usually you need only 1 or 2 fields, whatever you are interested in. So this is an example of overfetching. On the other hand, let's say we would like to get some data, but the single endpoint doesn't give us all data we need. At that point, we are underfetching the state, and we need to send another HTTP request to another endpoint to collect all data we need at this point. And this, again, affects mainly client because it becomes slower due to extra network connections. And also, we are sending more requests to the servers. So GraphQL solves both overfetching and underfetching that allows the client to request only the data it needs, and including relations. It reduces the number of requests to a server and reduces the amount of data that are transferred to the client. And again, this is very important on mobile or slow connections. For example, server, if there is some endpoint which would serve, let's say, expensive data or time-consuming data, we can include it in the response only if the client requires it and not every time. So it might feel a bit dangerous to give the client the power to query arbitrary data from the server, but actually that's not the case. The server is still in charge of setting the boundaries of what we can get, but the difference is, in REST, we define the response, and the client needs to take it all. But in GraphQL, we define like a set of all data the client can get, and the client can pick only the data it actually needs. So this is the main difference between GraphQL and REST. And now let's take a look at a few practical examples of how GraphQL queries actually looks like. So let's start with queries, which are like read-only operations. They are pretty much the same as GET request in REST. Using a query language, we can list all fields we would like to retrieve from the server, and that's all what we get. Some fields represent like concrete data types, for example, numbers and strings. And these data types are called scalars, and you can imagine them as leaves on a graph. In Python, using a library called Graphene, we could implement it this way. If you ever work, for example, with Django REST framework, you will find it very familiar. The class hero, which is like the type, is pretty much the same as serializers in REST framework. And the query is pretty much like a view. So it's about the same to implement GraphQL on a server. What's different, that GraphQL also allows us to query relations. When we have a field, which is an object or array of objects, we can query fields on this object as well. You can think of such fields as nodes of a graph, and that's actually how this query language got its name. That the schema is somehow is a graph connected by relations, and we are querying some subgraph of the data we actually need. What's important in this example, that the syntax for querying an object, in this example it's a hero, and an array of objects, in this example they are friends, the syntax is the same. The type of return value isn't defined by a query, but rather by the schema, which both the client and server has access to. So all we need to do is just list all fields we would like to get, and we don't have to worry about the type. What's interesting, that we can also pass some arguments to each field. We can use the arguments for anything from pagination, filtering, getting an object, getting a specific object by ID. For example, in this example, we are getting a human with ID 1000, which is the same as calling get request on a specific object. But we can also pass arguments to each specific field. And we have like more granular control over our data. In this example, we request the photo of a specific size. We can also pass the argument to the root query and make the query like reusable. So we can only we can later just pass another values for these variables and get different objects. So I'm gonna pause here, and I'm gonna show you a little demo. Let's hope it won't break. Cool. So far it works. Yes. No. Hello. This one. Ah, nice. So everybody can read it. I'll make it larger. And let's start with the first one. So in this example, I'm using API of GitHub. The 4 version of API is written, implemented in GraphQL. And you always start with a query, and then you start listing like the fields which would like to get from the server. So here I'm getting the licenses, and from each license I want to get the key and a name. When I run this query, oh cool, it works. Yeah, I get basically what I ask. I get a list of licenses with a key and a name. So since we have a schema, in this interface we can actually take a look of what type this field is, and we can see all data we can fetch from the server. And this is all defined in a schema, so that's quite useful. Let's take a look at the second example. As I said, we can pass arguments and get only a specific object, right? And we get only what we ask for. So in the last one, there's just another feature. For example, as you can see here, the name of the key in the response always depends on the field name of the field. So when we want to rename it, for example, when we are getting 2 objects from the same field, we can simply create an alias for it and get the data in a shape we need, right? So this is nice that the client actually dictates how he wants to get the data from the server, and the server is happy to give him whatever it needs. Right, so get back to the talk. Oh, right, I lost my, oh, never mind. So, now, important thing to notice, some of you probably noticed that I haven't been working with URL at all. Like in REST, you are changing the URL to get a different kind of data. So, it doesn't work like that in GraphQL. You probably guessed that we need to send some payload to the server, and all queries are sent as a payload of a POST request, even the read-only ones. So it might feel a bit controversial that we are actually reading from the server using POST request, but that's actually that's how it works. And it kind of feels as wrong as HTML in JavaScript, which React introduces, and it breaks any network caching. So we need to rely on application cache, but it has its pros and cons. So if you are okay with it, you can use it. Now, it won't be very useful if we could only read the state from the server. we also need a write operation to mutate the state. In GraphQL, this operation is called, as you might suggest, the mutation. This is the same as patch, put, post, or delete request in REST. So much like in REST, you are usually send some data which you would like to write to the server, and then you read some response back. So it's like write-read operation. In this case, the data which you are sending to the server are defined as arguments. Here, the create review, we are sending an episode and review. And we define what data we would like to fetch back using the same query as we would read it. So the syntax is the same as when you query or mutate the state. And it's really nice to have the ability to specify the fields which we would like to query from the server. But usually, when you write some object to the server, you want to get the same shape of object from the server back. So to avoid repeating yourself, in GraphQL there are fragments. So you define, instead of repeating the fields, you can just define a fragment and then include that fragment in a query. And it's especially useful if your query returns more than one data type. For example, here, the search query returns human, droid, and starship data type, and we would like to fetch a different field for each of these data types. So this is essential to use fragments here. And last operation, which is available in GraphQL, is subscription. And subscription are like queries, but instead they are not sent over HTTP, but over WebSockets. And they are basically used for notifications about new events on the server. So first you need to open a WebSocket connection, then send the subscription query, which looks exactly the same as a normal query or mutation, where you specify what subscription you are interested in and what data you are interested in. And when anything new happens on the server, you receive the data. Unfortunately, because GraphQL is pretty new in the Python community, the subscriptions are first something we need to figure out. I done it on one of my projects, and just to contribute, I posted it to the issue of a Graphene, and that gist is basically how is it used now, but it's still not implemented in the library itself. So we are getting there, but once you implement it in your own project, it's really nice to use it. All right, I'm gonna do this a bit faster because we are running out of time. So as I said, when you are defining your GraphQL API, you are writing a schema. And the schema is defined by types. Every value has its own type. And it's said that GraphQL is a strongly typed language. So just apart from the built-in types like string, float, integers, you can create like compound types like objects. In this case, it's a starship. And what's actually pretty neat about this type system, then you can create custom types. For example, since the response is for the response is usually used JSON, and JSON has only very few built-in types. So when you want, for example, have a date and serialize it to, which is usually serialized to string, in GraphQL you can define a custom type. In this case, it's a date, and then tell the server and a client how to serialize the values and deserialize the values. So you can somehow extend, build some abstraction above JSON to support more data types than what JSON has. And finally, since we have these types, we can get very nice validation. So, for example, client can download the whole schema at build time and validate all queries which you have in your application at build time when you are compiling JavaScript. So using this, you can catch the most common bugs. And there are tools like API and Swagger, which provide similar validation, but in GraphQL, the schema is first-class citizen, and it's not an optional feature. So when you define your API, you right away have this kind of validation. And it's also pretty useful for introspection, which we know from Python. So you can query the schema to get information about any type you have. And this is especially useful when you have, for example, an enum type, and in a select box you would like to list all possible choices. You can simply query the enum type, what choice it has, and then use it in a select box. So, as I said, because we are sending post requests, the network caching, we can rely on network caching, and we need to build an application level cache. And if you ever build a JavaScript application, you probably sooner or later, when you start fetching nested responses, you start somehow normalizing them. So instead of storing like a nested data structure in a memory, it's better to separate the different data types and store them separately, and then just glue them together when you are rendering. And since we have the type system in place, this can be done automatically by a client. But we can also go one step further. And what we can do that when we are sending a query, first we can look into cache if we already have all data fulfilling this query. And if we don't have, we can send the network request to the server and then store it to the cache. Otherwise, we just read it from the cache and save some bandwidth. It's a poor substitute for network cache, but at least we are using the maximum of the data transferred over the wire. And the last thing, since we have very finer granular control over our data, it's much easier to evolve the APIs compared to REST. So adding a field, it's easy in a REST as well. But here in GraphQL, all responses are completely unaffected until we include the new field in our query, right? But what's interesting, if we want to change or remove some field from the query, we can simply leave it there, mark it as deprecated using a decorator, and then create a new field which is supposed to replace it. And using this backward compatible process of upgrades, we actually don't need version our API anymore because we are doing it like gradually. And Lee Byron from Facebook said that we still support 3 years of released Facebook applications on the same version of our GraphQL API. And if you are using GraphQL Facebook API, you know they are deprecating some fields over time, but you have usually like 2 or 3 years to update your application, which is quite a lot. So GraphQL is gonna stay here for a while. Many companies use it already. As I said, GitHub, the 4th version of GitHub uses GraphQL. And just personal experience, as I said, on the server, it's about the same as writing REST API. But on a front end, it's much easier because everything is handled by the client, and it's actually more predictable to work with it. So, thank you. Sorry it was so fast, but we had a bit of shorter time. So just 2 questions. How many of you would like to implement your next API in GraphQL? Okay. And how many of you, I don't want to ask it, but how many of you would never, ever like to use GraphQL? Oh, that's good. At least something. All right, thank you, and thank you for listening, and also thanks for the organizers for putting up this conference.
Right, thank you, Tomáš. I think we have time for one quick question from Slido. So can you answer, what about permissions and access limitations, for example, for specific fields?
Yes, it's possible. Permissions are difficult every time once you start, some nested permission and so on. But since the server knows everything the client needs, he can limit access to the whole API or to the fields or just to the specific fields. And it depends on implementation. I did it for Graphene, like to limit the whole fields. But yeah, that's a good point. You have more granular control over the data, so you can limit not just the whole endpoints, but also the fields for given permissions. Right.
Right. Thank you. We don't have any time for more questions, but there will be a short break, and then we'll welcome our next speaker. So thank you, Tomáš.
Thank you.